Hi Algebra 2, this is Unit 8, Lesson 2, and today we're going to talk about solving square root functions. So if anytime you have an equation with a square root, the first step is you have to get the radical by itself. So if there's anything else there with it, you need to move it to the other side. And then you're going to undo the radical. The way we undo the radical is we take the square of both sides, and then you're going to solve for x. Now, as this last step, check for extraneous roots. Those are solutions that actually don't work, and we're going to see that on the second page. So here's how it works. We're going to start off easy, and then we're going to get more involved as we go on. So as long as you have the radical by itself, you're all set. Then you square each side. So when you square a radical, it just leaves it as x, and then 7 squared is 49. Boom, that's your answer. Okay? B, I still have the radical by itself. Anything, that x minus 3 is all under the radical. So as long as the radical is by itself, you square it, square both sides. So the square root of x minus 3 squared is just x minus 3. So by squaring it, it undoes the radical. 5 squared is 25. I add 3 to both sides. There's my answer. C, I still have the radicals by itself, so I square each side. By squaring it, I get rid of the radical. 4 squared is 16. I add 1, and then I have to divide by 2. So I get x equals 8.5. So those are fairly quick and easy. All right, a little bit harder. On D, I don't have that radical by itself. So I'm going to have to add 4. So I bring 4 over to the other side. So I have 3 radical x equals 24, because I'm adding 4. I still don't have the radical by itself, so I'm going to divide by 3. Now I finally have the radical by itself. So the way I get rid of it is I square it, and then I have to square the other side. By squaring it, I get x by itself, and x equals 64, because 8 squared is 64. All right, so try it with me. Get rid of the 7. You have to isolate that radical expression, and that gives me 6. I still don't have the radical by itself. I got to get rid of the 2. So I have radical x plus 5 equals 3. Now that the radical is by itself, I'm going to square it to undo that radical. X plus 5 equals 9, and I subtract 5, and I get x equals 4. And F, I'm going to add 4. And I have 5, radical 3x minus 2 equals 40. Divide by 5, and I finally have the radical by itself. So now I can square it. Squaring it, the radical disappears, and I'll add 2, and I will divide by 3. All right, so those weren't too bad. Those are kind of easy and fun to do. 2 is just same idea, but multiple choice. What is the solution? I don't have the radical by itself, so I need to get rid of the 3, so I divide by 3. Once you have the radical by itself, now you can square it. Squaring it just gets rid of the radical. I'm still left with that fraction there. So I have x over 2 equals 25, and then to get x by itself, I would be multiplying by 2, which means I multiplied this side by 2. X equals 50. Of course, whenever you have multiple choice, you can also just plug in those answers. All right. Number 3, a more complicated scenario arises when the square root expression is equal to a linear expression. The next exercise will illustrate this. So consider the system of equations shown below. So I want to solve it graphically. All right. So remember my normal square root. 1, 2, 3, 4 looks like this. Now I can certainly put this into my graphing calculator, but I can also graph it without my graphing calculator because I'm just shifting everything to the left 3. So 1, 2, 3, there's 1 point. 1, 2, 3, there's the other point. And 1, 2, 3, there's my other point. All right, so there we go. So now I'm going to erase the one that I had. So the red was that parent function. All right, but of course you can put it into your graphing calculator and you can just copy the table. That's what you'd have to do. Now y equals x plus 1, I need the m and the b, so my slope is 1. The slope is a number in front of the x, and b is my y-intercept. My y-intercept is 1. So 1 is actually my starting point. I'm just going to grab a different color, and then I'm just going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, all right? And I can even go down 1 to the left 1. And then I draw my line. Okay, so I'm just going to get this as straight as I can. And you can see there is a solution. The solution I'll do in red. The solution is right here at 1, 2. So I solved it graphically. Now, if I was going to try and solve it algebraically, all right, I just take the square root of x plus 3 and set it equal to x plus 1. Right, they're both equal to y, so all I'm doing is I'm taking each one and I'm setting it equal to each other. Now I have this the square roots by itself, so as long as it's by itself, I'm going to square it, but that means I also have to square the right. So by squaring it, it gets rid of the radical. Now remember, x plus 1 squared is really x plus 1 times x plus 1. You're foiling that. So that gives you x squared plus 2x plus 1, so be careful. I'm going to bring everything over to one side, so I'm going to subtract the x, and I'm going to subtract the 3. So I will have x squared plus x minus 2. Then I factor it. Okay, when I factor it, my factors are going to be x plus 2 and x minus 1. And then when I solve, my answers are x equals negative 2 and x equals positive 1. Now, here's the interesting part. Why does your answer from part A contradict with what you found in part B? Because if I'm looking at this, all right, I got one answer in part A. When I did it graphically, there's one answer. But when I did it algebraically, I got 2 answers. Okay? The graph shows 1 point of intersection. And the algebra shows 2 points of intersection. What happens sometimes in algebra is I get an answer that's not actually an answer. So those answers, the roots are the answers. The answers that for one reason or another are not really valid are called extraneous. All right, so those are called extraneous roots. They can always be found by checking within the original equation. So anytime we're doing this, we're going to actually have to take our answers and just plug them back in to see if they actually work. So let me show you how that works. So again, I have the square root by itself, so I'm just going to square both sides. And that will leave me with 2x minus 3. And when I multiply x minus 3 squared, now if you can't do this in your head, you're going to be multiplying x minus 3 times x minus 3 because you are foiling this, and you're going to get 4 terms, and those 2 middle terms can be combined together. If you can do it in your head and get right away x squared minus 6x plus 9, perfect. I need to bring everything to one side. All right, so I'm going to get x squared minus 8x plus 12. I'm going to factor it. So I need the factors that multiply to 12 and add up to negative 8. So those are going to be negative 6 and negative 2. I set each factor equal to 0 and solve. So I do get 2 answers. Now you got to take your answers and you got to plug them in and check them. All right, so let's say that my answer is 6. I'm going to plug in 6 right here. So I'm going to have 2 times 6 minus 3, and I'm going to take the square root of that. So 12 minus 3 is 9, okay. And on the right-hand side, I have 6 minus 3, and the square root of 9 is 3. So that checks. Now I'm going to check the 2. So 2 times 2 minus 3, but remember it's under the square root, equals 2 minus 3. Well, 2 times 2 is 4, and 4 minus 3 is 1, but the square root of 1 is 1, but yet on this side I have negative 1. This does not check. Okay, the answer does not work, so therefore it is invalid. So I leave it there, but I'm just going to put a line through it like that. All right, that answer does not work. All right, and we'll practice some more of these tomorrow.